Hey guys, Smail here. I created a RAG for searching products, and I really think this is a game changer for business owners who want to provide a unique shopping experience to the online visitors. This is not any type of RAG system, it's a GraphRAG. And in this video, I will show you how it works and how I did it. But before that, let me show you a demo of it. So here, for example, I will type in, I want red Nikes under $100. Let's hit enter and see what happens. Pretty cool, right? Let's try something else. Let's try blue running shoes under $150. Okay, not bad. So this is, guys, what you can achieve with a GraphRAG for e-commerce. It's pretty incredible, right? Well, this is possible thanks to this graph database that you can see here, with all the products, their names, their prices, and so on, and you will be able to access it too. Before we get started, at my agency NeuroFirst, we help all types of companies set up AI systems to increase their sales. For example, we helped an 8-figure US company get an AI voice system for menu ordering. We also helped another 8-figure US company, a discount store, boost their sales during the grand opening of one of their stores thanks to an AI and automation system we set up for them. And they were super happy with the results. If you also want to set up automation to increase your sales and margins, book a free AI discovery call through the link in the description or in the pinned comments down below. Some time ago, I built a prototype of a RAG system for e-commerce businesses. If you don't know it already, RAG stands for Retrieval Augmented Generation. It's a type of AI system. It uses LLMs like ChatGPT combined with your own custom private data to search and retrieve information from it. Normally, when you go to a website to buy something, you will do what we call a top-down search. So for example, for this website, you will first click on man, then you will go to the type of item, then you will use some type of filter. For example, here, let's just select the coats. And then finally, you will maybe sort by price. And then you will start looking, at the items that you might like. But what if you could just talk to the website in a natural way to get what you want? Now with RAGs, this is absolutely possible. And business owners can provide a unique customer experience via this powerful AI. If you are a business owner and you have some type of business like e-commerce and you believe that difference is better than better, then I think by providing this experience to your customers, it will definitely set you apart from the crowd of other competitors. Now let's get to how this works. I'll show you how to download the files. So first you will go to my community, then you will click on the resources channel, and then you will scroll all the way up, and then you will click on this link. Then here you will either create your account or log in if you already have an account. Then once you're in, you will click on this link. It will give you access to a zip file. Once you unzip it, you will end up with those files here. Okay guys, so before we start going into the details, let's first see a high-level view of the system. It all starts with the data. So here, as you can see, this is the data folder that I have that contains all the shoes that are contained in the graph database. So as you can see here, there are more than 3,000 items. So there are 2 files, per shoe. So there is a little bit more than 1,500 shoes in total. I used web scraping to get all of this data, and I actually used it from a website that allows crawlers, and you will see why. I got the data from this website called Shoe Palace. And all the products that are displayed here are under the URL /products. And the reason why I know that they are friendly with web crawlers is because of their robots.txt. So if you go here and then you do Ctrl F and then /products, you will see that there is no rule that this allows, /products URLs basically. Another nice feature of this website is that it provides the sitemap. So if you go to shoepalace.com/sitemap.xml, it will show, all the XML files, at least the XML URLs related to all their products, their active products actually. So here, for example, I will copy this URL. You will end up with this web page that contains all the URLs related to all the products of this website. And actually they don't have only shoes products, they have all types of products. But I actually had to write a Python script that goes over those URLs, extracts only the shoes items, and then for each item get the description, the price, the color, and some other useful information. Now, another important aspect of this project: why did I not use, simple vectors and vector embeddings, with the vector store to, store the information related to all the articles, and then just build, a naive RAG system? Because most of the people that show how to build RAG systems show just, the most simple, naive system out there. And those systems are actually not the best ones to use. Because, concerning online items, so first of all, you have multiple categories of items. You can have shoes, jeans, shirts, and so on. And let's take shoes. You can have multiple brands, so Nike, Adidas, Puma, and so on. And within each brand, you have multiple items. And if we take Nike, for example, you have multiple types of products. You have the Air Max, the Court Vision, the LeBron, and so on. And within each item, you have its price, its color, its description, and the style of the shoes. So why do I say this? It means that there is a structure within the data, there is a hierarchy. And if you split the data, just what people do in their naive RAG systems, you will end up losing this hierarchy, And actually there is a whole subfield of AI called data representation. So the way you represent data so that you can show it to AI models to ingest it is very, very important. And if it is not shown in a good way, then the results will be very bad. That's why for this project, Graph Database is the best way to represent data, so that we will store it and then search it and retrieve useful information from it. And if you want to dive deeper into the subject of GraphRAGs, there is a nice Microsoft blog post about it. So yeah, I would encourage you to go over it and to read more about the subject. I think this is very interesting. I'm actually a huge believer of graph representation of data. I think it's the mother of all data structures. And I also think graphs will silently play a major role in AI in 2025. I can tell you more about that if you're interested in upcoming videos. So now let's talk about the technologies that I use for this project. I use Python for the server as well as the RAG engine. I use Neo4j to store the graph database inside of it and to retrieve data from it. And then finally, I use HTML, JavaScript, and CSS to show this user interface and also to do the animations that I will show you later on. So first, we will download all the Python requirements for this project. You will go to the folder that you downloaded, you will find a requirements.txt file, and then in your command line you will type pip install -r requirements.txt. The next step is to download Neo4j. So you just Google download Neo4j, you will click on the first link, you will click on this button, and then once it is downloaded, you will just install it. You will see it is very straightforward. Now, after Neo4j is installed, you will open it, and then here you will create a new project. And then we need to create a new database that will store this data. So here, as you can see, I already have a database, but I will create one just to show you how to do it. You will click here, and then you will click on local DBMS. Here, name it whatever you want. I will call it tutorial RAG. And here for the password, make sure that you remember it because we'll be using it later on. I will just be using 1234 AZERTY. And then press create. It should take a few seconds to be created. Now the next step is to install a plugin inside this database so that we'll be using some advanced procedures and functions to retrieve the data from this database. So you will click on it, and then you will go to plugins, and then click on this APOC here, APOC, and then click on install. After it is installed, just press start to start the database. It should take a few minutes to start, 1 or 2 minutes, but then after it started, just click on open. You should see a window like this one. Now the next step will be to import our database so that we'll be creating all the nodes and edges that you've seen previously. The next step is to open the file cipher query ecomdb.json. Actually, this file contains all the cipher queries required to create our database. So Cypher is a query language that is specific to Neo4j, and it is used to create and then query the data inside of a graph database of Neo4j basically. And as you can see, it has a lot of statements. I actually wrote a Python script, to create this file, because as you can see, there are so many lines here, so many statements. This file actually has more than 13,000 lines, so yeah, it's a lot. So what you will do is that you will select everything. So you will just do Ctrl A if you're on Windows, or Command A if you're on Mac, and then you will copy it with the Ctrl C. You will go back to this window, you will click here, and then you will paste it. It should take some seconds to paste because it's a lot of data. Okay, now as you can see, all the data has been pasted. Now the next step is to click play. This will run all those 13,000 lines, and it will take some time. Actually, it will take around 3 to 4 minutes to process to create our database. So now I will press run. Okay, after it is done, you will see this message: added the 6,000 and so on labels, created 6,000 nodes and so on. So now let's double check that it is working indeed. There is a simple cipher query that returns all the nodes inside the graph database, which is the following one: match and then n between parentheses, return n. And then let's run it. So if this is working 100%, you will see the type of graph that is the result of this query. And here, it says not all nodes appears because I think there is some type of optimization for RAM usage and so on. But just know that if you see this graph, it means it is working. Now let's go through the files that are used in the system. The first one is chatbot.html. It's actually all the HTML, JavaScript, and CSS used to create this web page that you can see here. I wrote this function curve that is used to animate, every time there are multiple shoes that are retrieved, we want to animate them. So here, as you can see, we are using this delay and then animate, and we are playing on the top and left properties of each HTML element. Then another important function that I wrote is this create elements. So basically, this is the one that creates HTML elements once they are retrieved from the query. And you can see that here we are creating div elements with some image, and as the source of each image we have something in our database folder. Then the most important function in this file is the one that handles what happens once we press the enter button. As you can see here, we are using an Ajax request. So basically we are requesting something from the back end using this endpoint process query, and I will show you what this endpoint does. And here in this line I wrote that if we get at least one item, we should create those elements and then animate them with this curve function. Otherwise we'll just display sorry, no results for this. So let's see now how this process query endpoint looks like, and it is contained in this main.py file. But before that, we can see that this is actually the server file that launches our backend. And you can see that we are using this folder as a static database, and we are also using this HTML file that we just seen. Now this is the process query endpoint that we are interested in. So here you can see that we are using a function called query graph, to basically do all the processing. And this is a function that I wrote, and I will show it to you. It is actually in this Python file. But before that, we get the results from this query, and then if there are multiple items retrieved, we get the product ID, and we go fetch data from that folder that I showed you earlier that contains all those 3,000 files. And then we just take the information from the text file, we get the price, the brand, the name, we process it, Also, sometimes for some names, those are long names, so I trim it. If the name, the number of characters inside the name is greater than 24, then we just keep the 24 first characters, and then we just append them with 3 dots here. And then we return the result as a JSON, as you can see here. So now let's go back to this line, which is really the heart of our retrieval RAG system. So it says rag.queryGraph. And the query data is actually our natural language query. So when I wrote, hey, I want red Nikes under $100, this will be contained in this variable. But basically, this RAG that you can see here comes from the RAG engine that I wrote. And this RAG engine contains this function queryGraph. Let's see how it looks like. So this is the heart of our GraphRAG engine. You can see that this is using LangChain, and actually it's quite funny. I created this RAG engine almost 1 year ago, and at that time GPT 3.5 Turbo was very popular. So yeah, I just used that and it's still working right now, so why changing it? And you can see that I'm also using my API key here. The first prompt that is important is this one, the cipher generation template. Basically, it's the one that is supposed to generate a cipher query from natural language. And here I wrote a bunch of rules just to make sure that the AI will generate a nice query. For example, in line 7, I write the possible brands are Hey Dude, Lacoste, Crocs, and so on. Another important rule that I wrote is if you are asked about a brand in the plural form, always use the singular form instead. Because, in the Graph Database, there is no such thing as Nikes or Jordans. There is only Nike or Jordan or Reebok, So yeah, this helps the AI, generate the right query. And of course, I included some examples of questions and corresponding cipher query. So for example, for this question, do you have green Nikes between $100 and $150? This is the cipher query that corresponds to this question. So I won't go into the details of how cipher works. But yeah, if you're interested into that, just let me know and I will be happy, to have a video about that. And as you can see, there are 2 variables inside of this prompt. You have the schema variable as well as the question. So the question, is the natural question that we'll be using in our HTML file. And the schema is something that is used by Neo4j by default. It will replace this variable with a particular representation of the database schema, basically. And this prompt template uses this cipher generation template that we just saw here in this string. And then the next, we need to create a cipher question answer template. So basically this text here, this prompt, is used to generate, nice answers for our question. But for this particular system, we're not interested into the final answer, We are interested into the list of items retrieved through our query, because we'll, gather them as a collection of products, and then we'll process them to display them in a nice and specific way. And here again, this string uses 2 variables, the context and the question. The context is actually the output from the query that will be run on our Neo4j graph database. Then we need to define a question answer prompt, and this prompt will be using this variable here. Then we need to define a bunch of variables, so our Neo4j URL, user, and password, and actually those are defined in this .env file. So basically in this file you will write your own OpenAI API key. Here for the URL, just let it as it is, because it's the default URL used, so most likely you will be using the same one as the one that I'm using. And then the user the same, and the password, so remember I told you need to remember this password that you set, just write it here. And then finally we have this function queryGraph, which is this one that is used here in this file. So this function will combine our question the LLM, the prompts, and our Neo4j graph database to generate a new Cypher query, run it against our database, retrieve the results, and then get them. Now I will show you how to run the system. It's very simple. First, you will make sure that Neo4j is open and that your database is running. Next, you will go to main.py and then you will run it. Here you will see a URL, you will just copy it and then you will paste it into your browser. Here I paste it and then I open it. And here you will just type your query. For example, show me your blue Adidas, and then you will hit enter. So it should take around 3 to 4 seconds, to retrieve the data. And there you go, it is working. That was it, guys. I hope you enjoyed it. If you want to get more content like this one, you can like and subscribe. It will really help my channel. You can also comment down below if you have questions or anything else concerning those GraphRAG systems. Cheers, guys.